Okay, these are the solutions to conservation of energy 1. Our big idea with conservation of energy is that the mechanical energy, or the total energy, those two terms are interchangeable. For a system is constant. That means if I know the mechanical energy at one point, I know the mechanical energy at all points. So we have just two examples to look at here, and we'll do a whole lot more on the second worksheet. But with this one, we have a pendulum with a mass of 2 kilograms. It's going to swing down from A to E and back. And this table is telling me things that we know at each point. So based on the table at A, I know that my total mechanical energy is 36 joules. So the mechanical energy at A is 36 joules. But because energy is going to be conserved, the mechanical energy at every single point is 36 joules. So for every single point, the total mechanical energy is 36 joules. That's what it means for the energy to be conserved. So for that, once I know that, I can fill out sort of the height, potential energy, velocity, kinetic energy, rho for each bit of motion. So for A, I know the total mechanical energy is equal to kinetic energy plus potential energy. So the total mechanical energy is going to be 1/2 mv squared plus mgh, right? So that's how we're going to calculate things. I know the total mechanical energy is 36 joules, and that's equal to 1/2 times the mass 2 times the velocity 0 squared plus mgh. So mgh here is 2 times 10 times the height that we don't know. And so by plugging numbers in, what I see right away is that I have 0 joules of kinetic energy, which means all 36 joules of that total energy are equal to the potential energy. So my potential energy is 36 joules. My kinetic energy is 0. I know that based on those numbers. And then I can go ahead and solve for the height. I've got 36 is equal to 20h. Divide both sides by 20. And that gives me the height at A is equal to 1.8 meters. That's my height at A. So I'm going to go ahead, yeah, that's my height at A. At B, we're going to start the same way. Mechanical energy is equal to kinetic energy plus potential energy, and we'll leave the one that we don't know sort of blank. And they give us the velocity, right? So 36, we'll do this again. Mechanical energy is 1/2 mv squared plus mgh. So the mechanical energy is 36, and that's equal to 1/2 times 2 squared plus mgh, my potential energy. So 36 is equal to the kinetic energy 4 plus the potential energy mgh. So right here, I know that my kinetic energy is 4 joules. And if I subtract that over, 32 is equal to mgh. That tells me the potential energy is 32 joules. So 32 is equal to 2 times 10 times the height. So we'll divide both sides by 20. And so I get 1.6 meters is equal to the height at point B. For point C, things are a little bit different. At C, we're still starting the same way. Mechanical energy is kinetic energy plus potential energy. Mechanical energy is 1/2 mv squared plus mgh, but they give me information about height this time. So 36 joules, my mechanical energy, and using the same number for total mechanical energy every single time is the conservation of energy. That's equal to 1/2 mv squared plus 2 times 10 times the height of 0 meters. So I've got 36 equals 1/2 mv squared plus 0. So that tells me that my potential energy is 0 joules. And then I want to solve that for the velocity. And what that also tells me is that my kinetic energy, 1/2 mv squared, is equal to 36 joules. And so what I need to see in this row is that the potential energy plus the kinetic energy is always equal to the total energy. Potential energy plus kinetic energy always equals the total energy. Those two have to add up to the same thing every single time. So we'll plug in our numbers. 36 is equal to 1/2 times 2 times v squared. So 36 is equal to v squared. We'll square root both sides, and v is equal to 6 meters per second. So we'll move on to part D. Well, part D is nice. It's telling me I have 11 joules of potential energy. So mechanical energy is equal to kinetic energy plus potential energy. So 36 joules of mechanical energy is equal to kinetic energy plus 11 joules of potential energy. That tells me that my kinetic energy, subtract that over to both sides, is 25 joules. So I have 25 joules of kinetic energy. So 25 is equal to 1/2 mv squared. That mass is 2 kilograms, so 1/2 times 2 times v squared. So 25 is equal to v squared, and that velocity comes out to be 5 meters per second. So that tells me that my velocity here is 5 meters per second. Now I don't have my height yet, but I do know that potential energy is 11 joules. So I can say that potential energy, mgh, is equal to 11 joules. So 2 times 10 times h is equal to 11. So divide both sides by 20 to get rid of the 2 times 10. And I get that h is equal to 0.55 meters. And then point E, our last point, it's kind of the same deal. Mechanical energy is kinetic energy plus potential energy. Here they tell me that the kinetic energy is 9 joules plus the potential energy. So subtract 9 from both sides. So 27 is equal to the potential energy. So now I know my potential energy is 27 joules. So 27 is equal to potential energy, which is m, 2 kilograms, times g, 10, times the height. Divide both sides by 20. And that height comes out to 1.35 meters. And then for the kinetic energy part of it, they told me that the kinetic energy was equal to 9 joules. So 1/2 mv squared is equal to 9, or 1/2 2 times v squared is equal to 9. V squared is equal to 9, so we take the square root of both sides, and that velocity is 3 meters per second. So when it's all said and done, here's our chart. So everything we did for A is right here. Everything we did for B is right there. Everything we did for C will be in this nice baby blue color. Everything we did for D will be in this very hard to read color right there. And then everything we did for E is right there. I'm going to move on to question 2. So question 2, I have a roller coaster of mass 20 kilograms pulled up a steep incline to the first hill at 60 meters. Calculate the total mechanical energy of the roller coaster at the top of the first hill. So here, we want to know in part A what's going on at the top of this first hill. And we want total mechanical energy. Mechanical energy is kinetic energy plus potential energy. So it's going to be 1/2 mv squared, the kinetic energy, plus the potential energy, mgh. So it's going to be 1/2 times 20 times 10 squared plus 20 times 10 times the height of 60. So my mechanical energy is going to be 1,000 plus 12,000 or 13,000 joules. That's my total mechanical energy. So for this roller coaster, as long as there's no frictional force acting on it, mechanical energy is always going to be 13,000 joules. So then we're looking at point B, 20 meters above the ground. So at point B, right here, we want to know the velocity of our roller coaster. So to get that velocity, mechanical energy is kinetic energy, 1/2 mv squared, plus potential energy, mgh. Well, I know my mechanical energy, it's 13,000 joules. And it's equal to 1/2 times the mass, 20, times velocity squared. I don't know that velocity. Plus the potential energy, 20 times 10 times the height of 20. So I've got 13,000 is equal to 10v squared plus 4,000. My potential energy has gone down. It was 13,000, now it's 4,000, which means my kinetic energy has to have gone up. So when I subtract 4,000 from both sides, I get 9,000 is equal to my kinetic energy, which is just 10v squared. Divide both sides by 10. V squared is equal to 900. Square root both sides, and the velocity at that point is 30 meters per second. Calculate the velocity at point C, which is on the ground. So if we move on to point C, we're right there. It's the same thing. Mechanical energy is kinetic energy, 1/2 mv squared, plus potential energy, mgh. My mechanical energy for this problem will always be 13,000, and that's equal to 1/2 times 10 times velocity squared plus 0. It's 0 because point C is on the ground, and the height is equal to 0. So that means that all the energy is kinetic energy, or 1/2 mv squared is equal to 13,000. So 13,000 is equal to 1/2 times 20v, sorry about that, 10v squared. So 1300 is equal to v squared. That's what happens after we divide by 10. And that velocity comes out to be 36.06 meters per second. That's what the velocity comes out to be. Part D is asking about this unknown height h. So for part D, we don't know the height, but we know the velocity. So this time, mechanical energy equals 1/2 mv squared plus mgh. So 13,000 equals 1/2 times 20 times 18 squared plus the potential energy, m, 20 times 10 times the height that we don't know. So this time we're going to solve for the height. 13,000 is equal to the kinetic energy, 3,240 joules plus 200H. We're going to subtract 3240 from both sides. And so I get the potential energy is equal to 9,760 joules. So that's equal to mgh, which is 200H. Divide both sides by 200. And that height comes out to be 48.8 meters. So with this, we were just using mechanical energy as kinetic energy plus potential energy the whole time. Part E wants to know how much it would take to stop the roller coaster on top of the second hill. Well, work is equal to the change in kinetic energy. So work is equal to the final kinetic energy minus the initial kinetic energy. Well, the final kinetic energy, if we want to stop it, is 0. And then we're going to subtract the kinetic energy that the thing has when it is moving at 18 meters per second. Well, that's 3,240. So 0 minus 3,240 joules. So that work is negative 3,240 joules. In order to stop it, we have to do this much work, and it has to be negative because we are stopping.